Okay, so let's look at Galton's actual data, comparing children's heights and their parents' heights. So you can just do plot if you want to. It's right here. You do get a lot of these points in here. A lot of these points are overplotted. They represent several points. What I do here is I actually have the size of the point be the number of points at that particular child-parent combination. And the code is in the Markdown document, so you can do it. It's several lines of code, but it's nothing terribly difficult. So that's very useful. So what we'd like is to kind of what we're going to talk about is how do we fit some sort of regression. Oops, not what I want. How do we fit the best line through this guy? How do we fit a best line where the lines, how the line is fit is impacted by, how many data points we have at each particular combination. To start out with, why don't we forget about the best line in general? Why don't we do the following? Let's imagine I have some data, some XY data. Here's my Y and here's my X. And I'm going to put a pivot here at the origin at the point 0, 0. And then I want to just move this line in up or down relative to this angle right here, right? In a way that minimizes the distances between the points and the line, right? Now, the reason I'm tying it down at the origin is just because then I only have one parameter to think about how I move that line in terms of its angle. And this one obviously wouldn't be that good, so we'd want maybe this one would do a little bit better. Okay, so the way we do that, we can actually just go back to our least squares criteria. So a line through the origin is y = x beta, right? That's a line through the origin. It has an intercept set to 0. So if our xi and yi are our individual points and we fit the line y = x beta, then this criteria right there minimizes the sum of the vertical distances between the y points and the line, right? So if this is our line and we plug in xi, then the fitted value at that particular xi is yi hat, which is equal to xi beta. The distance between yi and yi hat is this vertical distance right here between the y point and the line itself. Notice it's not the orthogonal distance, right? It's not orthogonal, so that's a right angle. It's the vertical distance, right? It's the y minus what the line through the origin would predict given that particular xi value. So again, this is exactly the origin as a pivot point, picking the line that minimizes the sum of the squared vertical distances of the points to the line. And we can use RStudio's manipulate function again to experiment. And as a minor kind of technical point, well, not even a minor point, kind of an interesting point, we don't necessarily want the line to go through the origin. You wind up with kind of silly results, right? No one is 0 inches tall, so that the data isn't anywhere near 0. So we don't want pivoting it through that point 0, 0 doesn't make any sense. If we subtract the means of the parents' heights and the children's heights, and instead of analyzing the raw height data but the mean centered height data, then the origin of the scatter plot is exactly the mean of y and the mean of x. And in that case, then it's useful to fit it through the origin, because then we're fitting a line through the origin where the origin has meaning. We want to make sure it goes through the average of the data. Okay, so once again, let's actually use the manipulate function in RStudio to investigate what we're doing. Okay, so here we go. I give the code in the lecture notes, but then also you can of course get it from the Markdown document. So here's the idea. Here's our beta, which is our slope of our regression line, and it gives the mean squared error, which is the sum of the average squared distance, vertical distance between the points and the line. And of course, because these circles are bigger, right, that means that they're getting multiplied. There's more points that look like that point, so that they're factoring more into the sum. Basically, the sum is that point multiplied by the number of times that specific XY combination occurs. Okay, and so what the least squares criteria is doing is it's changing this angle And because we centered it, because it's a regression to the origin, and because we centered it at the average value, here we are, the point always has to go through this middle point right here, which is y bar, x bar, child height, parent height, and it's trying to find the best line. And you can see how the mean squared error changes, right, as the slope of the line changes. Okay, so here's the code that I used, and I just wanted to note, just because I probably didn't have the values set terribly well when I just did it. The slider, this changes the collection of slider values that you can look at, which I don't even think I was including the least squares minimizer point. So in the next few lectures, we'll talk about how you actually get the solution in R automatically and why this is the solution. But in R, the program for fitting least squares regression is LM. And here I'm just subtracting off the mean for the child. Here I'm subtracting off the mean for the parent. And -1 just means don't fit an intercept. R automatically fits an intercept. So -1 says don't fit an intercept. Data equal Galton is telling it the data set that is, or the data frame that it's working. And then here's what the output looks like. It's generally best to assign your regression fit to a variable. So you want to assign it to say fit equals this, or fit is assigned this LM statement. But we'll talk about that a lot more. But here you see the value that minimizes the least squares criteria. So the 0.46, if we were to plot centered child height and parent's height on the horizontal axis, and we had a pivot point right there in the middle. Up, it's not. There's my pivot point. It's a big point now. And for all of the parent and child combinations, we tried to pivot this to find the line through that point that minimizes the sum of the squared vertical distances. Well, the slope of that line, and remember the slope is the only thing we need for it because it's regression through, it's fixed at this point through the origin there, is 0.646. And in the subsequent lectures, we'll talk exactly about how you get these things, what you do to make sure so that you don't have to center the data first, and so on. And eventually, we'll even talk about how you can put lots of variables in there, not just parents predicting child heights.